Our panel on reproducibility, and everyone's going to talk about why reproducibility is a terrible idea and we shouldn't do it. Is that what we're talking about? No. So I think everyone agrees reproducibility is useful. This panel is to talk about practical ways in which we're taking pictures like it's like a and this is meant to be a community discussion, so I won't talk much. Everyone else is going to talk, but please come up to the mic as much as you guys want and ask questions. Welcome feedback from everyone. This is just meant to be a roundtable, asking questions, having discussions. And we'll just kick off with everyone giving like a quick introduction to what you think about reproducibility, who you are, all those kind of things. And the mic, and you have to share the mic over there, sorry. You can have this.
Start it.
This mic.
Do you want to start down here?
The water pitcher, or you have to stand up.
Okay.
Yeah.
Would anyone like some water, and then I'll just move it?
I'm okay with that one. You can move right out of the way. Okay. Have we cleared all obstructions? Can everybody see me?
Yes.
Okay. My name's Kaitlin Thaney. I head up Mozilla's first and main science program called the Mozilla Science Lab. I know that many of you have heard of bits of work from the Science Lab, from some of the projects we've had around looking at code as a research object and the idea of code review for science, as well as something called software carpentry, which is our training arm of the Science Lab. I have a former background of working on science at Creative Commons and looking at some of the architecture, also at digital science, looking at some of the tools. And so reproducibility is something that, for me, really takes a number of things working together, and also making sure that we're mapping that into the incentives and providing means for those that are not already converted, so probably people that are not already in this room, to weave that into their process. And I really hope that in the next, 5-10 years, hopefully sooner, but I'm just going to be realistic, we can get to that indistinguishable from magic layer where it's actually just the norm rather than the thing that we have to have special sessions about.
Does someone want to close that door in the back?
Do I need to take this to that, or are you going to?
I can do next. Just say
Cool.
next.
Okay. So my name's Varsha Khodiyar, and I'm here not on my own merit, so I'll just say that up front. I'm here representing the journal F1000 Research. So F1000 Research is quite a new journal, but it's completely open. We do lots of things very openly. So I think that's why we're asked to present today. So this is I've just quickly pulled together some of the things we do regarding software. So we do ask for all of the data supporting the findings that are being presented in the paper. We ask for the source code that's been developed for the paper. We appreciate sometimes people use proprietary software and then they just need to include a link to where that can be found. But if they've developed the code, if they can include it, it makes it more open. We've got a collaboration with Zenodo, which is a repository funded by CERN and GitHub. So if an author has source code in GitHub, we then take a copy and put it into Zenodo in order to mint a DOI, and we've been doing this for some time. And we have a data and software availability section as well, so we try and make it very clear to readers of the paper where you can find the data, where you can find the software. And of particular relevance, I think, to this particular audience, we allow articles to be updated after they've been published, after they've gone through peer review. So if you have published a paper on some software and you tweak the software, so it's probably not enough for a whole new paper, but you can update your article so you can keep your article in line with your software updates. So next, please. So my colleague Michael Markey presented this yesterday, so I'm not going to go through in much detail, but this is just a closer view of the software availability section. And I'm happy to talk about that later if anybody wants to hear more. So this is just a bit of a brain dump, really, from me. How can journals support the publication of reproducible research? So I've just put a few ideas up there. I think we're all really aware that as journals, if we put too many if we ask for too much from authors, we're actually putting up a barrier for publication. So I think there's a balance that we need to strike there. And that's just, if you have any ideas of what you'd like to see from journals, we're really happy to take on ideas and work with authors to try and do this as reproducible as possible. So these are just some ways you can contact us.
So, hi, I'm Phil Bourne. I met most of you this morning. I'm here for the second round of being beaten up. So I guess I'm here wearing sort of three hats. One is a NIH funder of sorts, which you heard about this morning, I guess. One is a sort of person who's quite heavily involved with the Public Library of Science and is involved with their data sharing policies and other innovative things that we might do around reproducibility, which hopefully you can talk about. And then the third, of course, has an investigator in my own lab where I can't reproduce things that I do. So I'll be happy to talk about those too.
Hi, I'm Titus Brown. I'm an assistant professor at Michigan State. I'm really loud on Twitter. And my lab has been working to make our own analyses as reproducible as possible. And we found that reproducibility is its own reward. So I think my message is try it. You might like it.
Cool. Do people want to start off the discussion?
Go on. So what? Could we have a bit of clarification about what precisely we want? We really want when we talk about reproducibility, because to me there are several different levels this can occur on, and very often what we seem to be talking about here is rerunning the computational pipeline at the end of an experiment. Ian Gent on the Software Sustainability blog came up with a rather nice term for this, recomputability, which I sometimes wish was used to be more specific. So then there's a next level where you have the same level of replication support for the wet lab bits, but then perhaps you have even a greater level where real reproducibility means someone else starting with a similar idea but not taking the same methods and coming up with the same results. So is there a risk that recomputability could be, the focus on recomputability could be getting in the way of true independent replication?
Okay, I'm just going to grab the mic. Okay. So it's a good question, and I think it's probably one of the thornier issues that surround some of this. I mean, in the same sort of way that despite advances in what we call open science, there are still people that, because it's got open in front of it, won't get near it. I think we are teetering towards that with the whole reproducibility, replicability, recomputability aspect. This actually came up at dinner last night, which was not actually with anyone that was supposed to be at this conference, just in a general sense, because there was a Harvard piece recently about the dangers of reproducibility. Did anybody read this? But there was the one person in the audience, I don't know if there's anybody else, but was really getting it. I think it's a slippery slope when people start talking about the end goal of reproducibility and how it's just, that's not how science is done, and these various aspects. It gets it away from at least what I would think of it as, and that to me is making sure that all the different components are made available, and that's not something that's thrown together when people only ask for it, but it's just an inherent part of the process. I think in certain disciplines, you get closer to being able to computationally go through and verify, and those are the additional niceties of it all. But the recomputability aspect, that limits it to computational research, and I think that this is bigger than that.
I think I'd agree with what you said. As software developers, you have to remember, and especially if you're working in the bioinformatics space, you're actually writing software that's going to be used by non-developers. So I'm speaking very much from personal experience here. When I was, working in research, I wanted to take a piece of software. I wanted to know roughly what it did. I want to know that I can use it and what kind of input file I should have and what's my expected output. I don't really need to be messing around with the code, but that was where I was coming from. So I think people have different levels that they need, different levels of information they need, and that's actually part of the issue. So, when you write a paper or you make your code available, how much information do you need to put in? Because it depends on what audience you're aiming at.
I don't think I've ever done anything that anyone wanted to reproduce. Truly, I mean, I think people want to reproduce if it's so good and controversial it can't be correct, or it's so bad that you have to really reproduce it exactly. I think the notion of replication, of course, is a different matter, and it's got, in the broadest sense, it's got nothing to do with computation, although of course that's where we're all coming from, but. The idea that that you can in some way replicate, which from my point of view, and I'm sure I have very naive thinking about all of this, is really just the ability to get reasonably close to what somewhere to convince myself that the methodology was sound, even though the results are not identical, because it's firing off different versions of software, it's using different data sources, and so slightly different parameter sets. But I can see from the work that I've actually been able to replicate it, and for me that's enough. And
I'm not sure I have anything to add. I guess I would say that my biggest concern when I read most papers is that they are not, in theory, reproducible by anyone at all. And so I worry a little bit about the engineering types who want to pin everything down, who want to pin the butterflies down to collect them and say it has to be 100% recomputable and reproducible and replicable, and here's how we're going to do it, when really the problem is we're so far away from the goal that I think defining an endpoint is perhaps premature.
Do you want to talk about how that could contribute to remixing stuff? I know that's something you're interested in, and that seems like, I mean, I don't know, that seems like a apt topic.
So go to http:// So there's a separate issue, and I've written about this at my usual great length. Thanks for the reminder. That there's accelerating the process of science itself, and that's, I don't know, orthogonal is probably a strong term, but it's not directly aligned with the goals of replication and reproducibility, where you want to be able to riff off of what other people have done. And I think that's a separate, important, I'm being gesticulated at him, okay. Yes, use a mic. Being able to build off of what other people have done before you is incredibly important in science, and I think that gets lost in this discussion as well. And it's not entirely uncoupled, but it's not the same thing either. Because I can give you, just one of my favorite arguments, I can give you a virtual machine that does perfect replication, but you can't do a darn thing with it. And is that useful? No. Is it highly replicable? Yes. Anyway, so.
And I think that there's also the aspect of it about just trying to reduce friction in the system. And a lot of this is just increasing the friction. And everyone has their own sort of separate context for what they want. I mean, and worth saying as well that replication, when it comes to economics and some of the social sciences, it's actually baked in as a way that they learn statistics, right? Like, there are different advances in different disciplines and different things that we can learn from those different groups. But I think one of the thing that brings to mind is there was a workshop that Titus actually organized last summer at Succinct in Annapolis, and someone that was completely separate from the scientific research context. We were talking about some of these issues in one of the working groups, and she goes, "It sounds like researcher hygiene, that you just need to up people's researcher hygiene," right? And then it goes back to, and I'm going to attribute this to Carol, because this was the first time I heard it. It was about 7-8 years ago, about you're more likely to find people that will share their toothbrush than share their data. And there's a lot that actually starts to make sense, right? But it's, it shouldn't be as hard. And I think that to me, granted, it's really hard to quantify that or to measure that or to hold people to that, but instead of getting stuck on the details of, well, I'm working at this altitude, so this isn't going to actually work if I'm trying to reconstruct someone else's experiment, so your whole argument is bollocks. Like, that just, it's a straw man. I think that working towards reducing the friction for research and understanding that this is not, it shouldn't be as difficult as it is, because it's wasting time, it's wasting money, it's wasting resource. Those that are working in biological labs, how many times have things expired because no one was actually managing information properly? It's like jugs of milk, very expensive jugs of milk in a refrigerator. But I think that we need to reduce that friction.
There's a term that I came across in Silicon Valley speak, permissionless innovation. I want to be able to take your work and build off of it without having to ask for permission from you. And I think that that's been essential for progress in many technical disciplines. And we can't do it in biology right now, all too often.
Yeah, it's a great point, because I mean, GitHub is like completely different. Even it's conceptually not that different from SourceForge and whatever we had before, right? But it is conceptually totally different, because people need no permission to fork your stuff. They don't need permission to go have access to your CVS repository and everything. So it's a great point.
So I'm going to thank Thomas for asking my question, and I'm going to re-ask it because I don't think anyone gave a good answer. So I'm going to frame it a little differently and pick two terms: repeatability and reproducibility. And what I heard answers before were for repeatability, being able to take someone else's work and repeat it. So that's sharing code, sharing data, repeating it. Reproducibility is, in the semantics that I'm using, is a much more fundamental concept in science. It's being able to take someone's work, read a description of it, understand what they did, the methods they use, and reproduce that result independently of anything that they gave you. That is a much stronger version of remixing, a much more stronger person. That's how science and software, I mean, anyone who has, Newth on their bookshelf, that's reproducibility. These are descriptions of algorithms that we can go and reproduce and verify that they work and understand them. And when you're looking at how publications work, I want a publication that I can go through and read, understand the methods at a level where I can go implement it independently of what you did. I could care less about the code you wrote, because if I just rerun your code, I'm repeating what you did. And if your code is wrong and I get the same result you got, that's not reproducing, that's repeating. It's very different. And I think there's a big difference in there, and I love all the infrastructure we're building to share code and share data. I think that's all really important. I think repeatability is really important, but I think we really need to be careful as scientists when we claim we're doing one or the other. And I think reproducibility is much stronger, but it's also a much harder thing, and it's something that I haven't yet heard talked about in any of these discussions. So I'm going to throw that back to you guys.
So what you just described is called friction. But thinking of the components that are necessary for that, if someone's going to have a deep enough understanding, and granted, there are changes that need to happen at all levels, right? Like, this isn't just on the researcher end, though there is onus there. It's not just, it's also with publishers, it's also with the technology stacks, it's also with the funding agreements and how these things are all driven. But I think that if you don't have access to any of those bits, you don't have the things that can foster a discussion so that people can actually get that understanding, that becomes much more difficult. And being able, what we were describing here about being able to actually take and repeat, or the repeatability definition that you gave, that to me is the nice to have for someone to be able to do those things, but you need to have the components listed there to even be able to have that understanding to do, or the jazz on top of the actual script music.
Sorry. You two should have sat together.
Yeah, sorry. That's okay. We'll just loop the. Never mind. I think this actually comes from Kay. So at some point I argue about this stuff all the time on various blogs and whatever, probably with you. I recall asking somebody, well, what do you usually respond when people make this distinction? And they said, well, suppose that you take my study and you try to reproduce it and you fail. If my study is not repeatable by me or by you, then what are we talking about? So I think the distinction between necessary and sufficient. If it's necessary that I be able to repeat my study for you to even begin to attempt to reproduce it. And we're not there yet. So let's not talk about, so I would say that your question's invalid. We can't even talk about.
We can talk about the next level too, but don't use the term reproducibility for that. Because it cheapens thousands of years of science to use the term in repeatability.
So different fields, this is a vocabulary problem. So
I'm a computer scientist, so I'm using terms that make sense from that side of the world, which is very most people in this room.
But that's why. Thank you. But so this is to go back to that initial bit in that conversation I had at dinner last night. That's what is further polarizing. It's exacerbating the problem. It's exacerbating the divide. For what we do at Mozilla, we're in a really unique position because we are trying to reach various audiences and disciplines in different regions, and even like the Broad versus MIT versus Harvard. They're different cultures, right? They're subcultures, and so trying to find trying to, sorry, for those in the room that are from the Broad, trying to figure out how to get this to resonate across, but spending too much time on the semantics is actually keeping us from looking at what we can actually do together to move that forward. And I think that understanding the relationship between them, and that's a really useful way of putting it out, but saying that it cheapens science as a base is also, I mean, I would push back on that and saying that what cheapens science is the fact that this hasn't been fixed yet. The fact that people have accepted this as okay for hundreds of years, I'm sorry, that's absolute crap. And that's going to be on Twitter in about 6 seconds as well. But but it's frustrating and in a way that keeps me employed, that this is still a conversation that we've had for about 10 years. I'm going to start to go white, and you can see me wither as it goes through.
No, you've gone red.
Yeah. Well, and I think we can learn a lot from different groups, and we're having these discussions, and we're really passionate about it because it's a hard problem, and many people are frustrated about it. Whether you're in the trenches in research, whether you have someone that's afflicted with a rare disease that you are still watching people cycle on, whether you're coming at it from computational science, and so it's a really, really great point. But I would say it doesn't necessarily cheapen that; it's already been cheapened, and we're just trying to get it back out of that.
Carol?
Oh, okay, sorry, I was drifting away there. So I was in danger of exploding on this reproducibility, reusability aspect. Every time I give a talk on this, I always have to explain exactly what I think and then work on that. But there is a serious issue here to do with the reuse aspect, the remixing aspect, that we're really talking about, are we creating a computational environment so I can pick something up and run with it, or am I describing something well enough that I could rebuild it or repair it if there were components missing, or if I wanted to write some new implementation of the algorithm, for example. And actually, I think we're in danger of thinking, well, the easy thing is to just package everything, and practically everything we heard about was packaging, and the hard thing is describing it well enough so that some other guy could repair it, perhaps because that library doesn't exist anymore, or I want to implement something else. That's much harder. But actually, that's kind of what we want to do. So I think we may be driving towards the computability, going for the easy is easier than it is than doing the reproducibility description stuff. But the question I really wanted to ask was about flirting, which is permissionless innovation. Because at the moment, in particularly in biology, and all my experiences of building of platforms is we don't have a permissionless environment. We have an environment because of the way that we reward people that encourages flirting. So that what I mean is I'll tell you enough about my software in a presentation so you'll be really interested in it, but you're going to have to take me on a date to be able to use it. And preferably put me on your grant as well. And we see this prevalently in data. So it's not that it's hidden, it's that it's kind of partially hidden. So how do we get over that? And this is part of the reward scheme, because this is tied with, it is not in my best interests to allow you to have complete innovation without me getting any kind of response to that. So has anybody got any ideas how we can improve that situation? Phil, for example, with money, that might be one.
I was trying to add on to the datings thing. I was thinking about teasing of various kinds, and I've completely lost the thread. Well, I mean, what you're talking about, if I'm making it very simple, you're talking about the appropriate reward schemes for being whatever semantically we choose to call whatever it is we're talking about, right?
Yeah.
And as I was sort of started to allude to this morning, but I think to build upon, I think there is, it's slow as can be, but there is growing recognition that we need to be rewarding different things than we rewarded before. And I mentioned, I think, was it this group or another group, that the bib sketch, for example, in the NIH has just recently changed to try, and there was quite a lot of pushback from that, by the way. But the idea was to get away from the fact that I've got this huge long list of papers in Science and Nature and Cell, and that what I really have is some innovations of all kinds, whether they be software, data I produced, or whatever it might be. So I think these are definitely sort of steps in that direction. We're also, I think the funders are interested in beginning to, fund different kinds of things and different kinds of people that that reflect this. So, again, it's the idea that there are rewards to be had for different kinds of people than the typical tenure track people. I mean, we're going to start seeing more of that kind of award given out, so that it goes sort of hand in hand with whatever bibliographic sketch you have. But the fact that, if you don't have a very high H index, but you've actually done some really innovative things in software, then you should be able to get, it's clear that you're likely to do a better job if the grant relates to software in some way than someone who hasn't. And I think that kind of realization is coming, but it's not there yet.
So can I respond to that? So one of the things I heard that was really exciting, because I need to get out more, I know, but that in the Code Fest was that Galaxy, and I know other systems are doing this now, will automatically detect that you've used certain software and set up, this is what you should do to cite that. Because it isn't just, making out that, putting things out and you getting some reward for getting something out, but you have to get people to cite it in order to build a citation index. And it's really hard to persuade people to even cite papers about work that they're using, let alone software and data. So we do need, but we could do something to at least automate that, to help that, to reduce the friction. So, it's closing the loop. So I would really like us to see, as BOSC, if there are ways that we can do things like push to people, you use this data, go cite it. You use this software, go cite it. And if you publish a paper where we know you use this software and you haven't cited it, then the Titus Brown police will be on your arse or something, I just picked that because...
I mean, if this group, one of the things that came out of the workshop that was held recently around software was is software citation. So if this group could just come up with, a scheme for actually doing it, that, we should, this is not a new thing, but and it seems like no one ever there's never enough agreement that says this is how we want to cite this particular piece of software with its associated authors and its associated version. If we had the ability to do that in some way, then, I would be more than willing to really push to have that adopted as something that was accepted within this framework, which would mean actually in grant applications and ultimately in certainly whatever publications that few they are that I have some influence over, we would do it. But I think it's got to come, whatever it is, has to come from this seems to me the best community to be able to do it. So tell us what it is and we'll implement it.
Can I piggyback off that for a second? As someone that was in that workshop, and also from your presentation earlier where you said that there was also the pilots and the prototypes that you're going through, at least in our sense, what we've found is that death by committee or death by discussion is something that's really kept us from getting this stuff to be pushed forward. And that just getting out and doing it is really important, but that also it's not enough for one organization to lead that if they are, say, creating one bit of that infrastructure. So, I know that we had a whole Twitter conversation earlier today that, getting GitHub to issue DOIs for everything is probably not going to happen. Getting a publisher to glom together all the bits of infrastructure and to liaise with everyone else in their community, it's not in their competing interest. And this is what we've been trying to do for our technical work, is to say, let's see if we can get people around the table, put it in a forgiving environment, so that if that works, then we can put it into something there. So I think that understanding that there are groups that can help out with that middle step so it doesn't seem so all or nothing might be a way of showing some incremental progress. And also seeing what doesn't work so that you don't have, millions of dollars invested in something that doesn't move.
Can I So I don't know if people are familiar with the Force 11 group. So they've been going for some time. And they've been fairly successful in coming up with a set of data citation principles. So, and then it's up to different journals and publishers and people to kind of implement them. And there's still there's now a group saying, talking about how to actually implement these principles. But actually just coming up with this core set of 8 principles has been really useful for us as publishers. And yeah, if the community could get together and come up with a set of software citation principles, we'd be really happy. And I'm sure other publishers would be really happy to contribute what we can, but also to implement them once they've been decided.
So I'm a little confused. So, yes, I think that, and I certainly was involved with Force 11. I think it's a great step forward. But I'm just going back to Kate. So, what I thought I got from you was that, okay, it's no good for me just to sit here and say, tell us what to do and we'll do it. You're saying then you're saying, well, we can't really tell you. There's going to be this. Where's the solution here?
Can I speak
Of course.
I'm not saying that we can't tell you what it is. I'm saying that if I were to write up a way to, and we in this room were to write up a way that people should be citing software, which already has been done multiple times over, and were to put that in front of you to exert top down, I mean, that's one way to do it. But also, like, for example, to show how the system works, I mean, there were ways of assigning DOIs to software before we had that project, but it was getting the buy-in from the computational researchers who were helping to establish best practice, the technical layer, the publishers, the libraries, et cetera, and then, looping that in with the funders. That makes it a little bit easier for people to feel like they've got some ownership over, which makes it even more tractable. So it wouldn't just be within the group of computational biologists, but it could possibly be opened and have other groups feel like they've got a stake in it, and also have that early adoption. Because I think a lot of the discussion that we've had today about some really fantastic tools and principles and standards and things that can get us closer to reproducibility, or however you want to define it, it's wonderful, but it's lacking the adoption. Like, there's a reason this stuff hasn't tilted yet, and this is just my hypothesis, that having a way of having some tests to show what it looks like in application, it's a lot easier than saying, nope, from this point forward, everyone has to do it, because that's where we hit the real challenges.
Well, I think you're talking about, just to sort of summarize, I think you're talking about like carrots and sticks, right? Like, and I think you're talking about carrots, and Philip has a stick, right? So it's good, right? So everyone is, we're all aligned, and you probably need both of those to actually get to the final solution. Just to make the case. Just to get there, yeah.
So I'm having trouble articulating why I disagree with everything you've all said. But I guess I would say
You can't reproduce it.
it's been recorded, so I'm not so worried about that. And I'll just make up quotes anyway. The concern I have, so I had a very illuminating conversation with a foundation program manager, and I won't mention names because I might get them in trouble, but people are the problem, right? Phil here can do whatever he wants in terms of allocating money. Well, maybe not whatever he wants, but he can allocate a lot of money to things, and for good reasons, they still have to go through peer review. Kay and, Varsha, can provide as much in the way of technical solutions as they want, and still nobody will use them, because you can't be successful. The path to success goes through this is being recorded, through the senior scientists who don't get it. And I don't know what the solution is, because it's very hard to become a senior scientist if you work in this area, because there's no way to become successful without pass. Anyway, so you get this sort of sense. So I don't really know what the solution is. I just feel like we keep on talking about technical solutions. That's great. They're wonderful. I use them. We keep on talking about how we just need more money. I'm not going to argue against that. But there's a generational component that I do not know how to deal with. The program managers get it. The funding bodies get it. We get it. I don't think that's clearly not enough. And I don't know where to go from there, but that's my articulation of the problem. the publishers are, I mean, everybody's wonderful, right? We can do all of this stuff, but but nobody, Microsoft Elsevier, you didn't see my talk, but there's a missing component that is a people component, and your comment that if it has open in front of it, people are leery of it was very revealing, and I get frustrated. Anyway.
Brett, do you want to?
Hi, Brett Smith from Curaverse, and I definitely come to this community from the software angle. I've previously been at the World Wide Web Consortium and the Free Software Foundation, and there's sort of interesting parallel timing to this for me, because there's actually been a lot of talk in the free software community about the reproducibility of their work, especially in the context of recent NSA revelations by Snowden. Like, people are asking, is it possible to recompile Debian? Can I take all of Debian's source code and get the same binaries that they get? The answer is no, at least today. And that's disconcerting if you're trying to convince yourself utterly that the software hasn't been tampered with by spy agencies. And so this strikes me as an interesting parallel for two reasons. Titus, you mentioned that like you're interested in aspects of reproducibility beyond just the bits, and I think like there's some evidence here that you can, like, to the extent that you all are trying to make this science more like the free software community, you can see that it's definitely possible to have a lot of success. Like, nobody would dispute that Debian has been successful, has provided a lot of value to a lot of users. And I think you can, even though apparently you can't get perfect reproducibility bit for bit, as you might ideally hope. So I think it shows two things. One, it's possible to get a lot of value without being perfect. And two, that in some ways, software is a much simpler problem for this, right? Like, it should be very simple to take just these source code files and run it through this compiler and get the same binary out the other end. But even that's really complicated. So if even the computer scientists can't figure out how to do reproducibility on that level, like, I hope you all recognize the challenge of doing it, given like multiple different kinds of inputs and analysis tools and coming up with the same analytical result at the end of it. So it's just, I thought it was an interesting parallel and wanted to throw it out for background.
So I got in a loud argument in December with somebody who said, who worked in a similar organization to you, making reproducible workflows, and they said very proudly, and we can go from, we can re-execute any analysis from scratch and get exactly the same answer. And I said, well, two things. First of all, probably you really can't, but let's put that aside. And he actually suggested using Haskell because functional programming language. It was like, okay, anyway. It's wonderful, but it's besides the point. And the other thing is, there's this weird facet in sequence analysis. There's this weird biomedical community requirement that things, and I don't actually know if it's NIH or if it's NIH's fault or not, but that you be able to replicate an analysis exactly down to the parameters in order for it to be not to be sued. I think is the rule. If you predict somebody has a particular kind of cancer, you have to, for legal reasons, they want you to track everything you've done. And the problem is you're taking, think about Illumina, you're taking this tremendously complicated chemistry, you're taking these CCD images of millions of spots, you're converting those into sequences via some magic, you're then taking those sequences and outputting them into FASTQ format, and that's all of a sudden sacred. And then you're taking that sacred FASTQ format and passing it through some pile of crappy C code that does variant calling. And then somehow the parameters to that are sacred. We have no idea whether it's accurate, but we at least can be precise. And then that is somehow providing some unknown amount of value, and we care about all the details of that. But what we really should be caring about is higher. I mean, we should be caring. I would prefer to have a random number generator built into every variant caller, and worry overall about the consistency of the analyses between different variant callers. I think that is a more appropriate level of concern than this sort of, can I get the bits right? And But I do like the parallel, even though I just told you I didn't. I just get really worried. This technical, I think Kay and I are on the same page. This idea that somehow if we can't get the bits exactly the same, then we failed is exactly the same as maybe a little strong.
Just connecting that point with, what you just said, Titus, prior to that. I mean, do you guys feel like there's a parallel in terms of how software has changed, in terms of how science can change? I mean, there's been a huge change in terms of the openness of software and sort of leading the Free Software Foundation, and you sort of mentioned the roadblocks. I mean, I'm sure there are similar roadblocks for computing. Do you guys think there's anything we can learn from that? Just. Then it's fine.
So don't knock over your cup. I think that we've seen some of that happen in disciplines where it's happened out of necessity. And I think that some of the work from the open source and also the free software side of things came out of necessity back when it was a bit of more of the Wild Wild West. Like it would be interesting to see if something like the Free Software Foundation, if it were to come into being today, how that would all come through. And I mean, we've all had stories of archive and how the higher energy physics community, I mean, they would put something out when they would declare that they were going to start working in an area and use that as a way of inviting feedback and also collaborators. And that seems to a molecular biologist like heresy and just absolute nonsense, right? And I think some of the discussions about disciplines that in the same sort of way are working off of shared resources or limited instruments where they have to do that out of necessity. I don't know how much of it may be drawn on that side where, unfortunately, because there have been so many other complicating factors that have gotten us into the social predicament that we're in now, if that's where we're tripping up. And that the technology, yes, it moves us a little bit by bit forward and moves communities that know that the technological bit exists bit by bit forward, but there still are a lot of other people that don't. I don't know if that just is kind of pushing us really step by step forward.
I could definitely speak with a little authority here because looking around, I probably am the oldest person in the room. And I'm sorry, Carol, I didn't mean to look over. You're young. I know. But I was involved in a project in 1978, I think it was. It was called CCP4, the Collaborative Computational Project for Protein Crystallography. And there was a whole series of these projects that were funded at that time by the MRC in the UK. And they had absolutely a profound impact on that science because, there was no internet, all that stuff. People got together, they shared code, they wrote code together. There was a limited group of people who just sort of oversaw it, and then that was distributed on tapes to, I'm sorry, I sound like, but you don't have that frame of reference, but that had a very big impact. And that is tiny compared to the impact that you've all had by what you put into these various repositories like GitHub and SourceForge. So, you just don't have that reference. But it has made an enormous difference. It is propelling things forward in ways that we didn't have. So you should really give yourselves a clap for that. But now we're kind of splitting hairs about, in some senses, the nuances for the next step. A lot of what I've heard in this discussion in the last, and I'm about to leave to go and give another keynote, so you can beat me up after I've left. But I think it would. This to me is the smaller part of it. I think it is the people problem. I think that is what that's where, the technologies, I wouldn't focus so much on. I would focus on really how whatever you can do to change the person perception within this is by far the biggest piece. That I'll have to leave, sorry. Thanks. But if anyone wants to kick back on that, it's fine. Yeah. Hilmar's going to have a go.
I just wanted to follow on that. Mentioning isn't that the people problem? And so I would like to ask: isn't the people problem? So from my own personal experience, all the faculty and scientists I meet with, and there's a lot of them through the center I work at, they're all very open. In fact. Almost surprisingly open to the question of reproducibility and to wanting to improve the reproducibility of their own research. but they've made a little bit of headway or a few experiments, realize it's very hard, especially to do it as it's commonly touted, like, from end to end, et cetera, and then they give up, right? So isn't this people problem to a large extent a training problem?
Well, I think it's sort of an education problem. And I mean, just as you were speaking, I was thinking about another part of it. It's really about, cost-benefit ratios, and that sort of comes back to the rewards. So, even if you train the people to do better, if the system in which they're working is not rewarding it, and we've heard it all before, so this is nothing new, but it seems that I'm just sort of adding that has to go hand in hand as well. But yeah, I think, the training is a key part of this, and I think that's where in some ways that you now are training people, and that they will then carry forward the message, but that's pretty slow. And it would be nice if you could think of ways after I leave for speeding it up.
So first off, bye, Phil. That's all painfully watched. But I think that, Jonathan brought up a really good point talking about process, about open process. I think that part of it is how do you get the incentives aligned, right? Like whether that's measuring other things and rewarding other things in just a published paper because that's what people are working towards, and they'll scramble to that last bit and they'll push something out the door and hope that it gets that next grant. And so there's a role for funders, there's a role for those that are working the US is a little bit different because it's a bit more of a black box when it comes to promotion and tenure, but if you're in the UK or Australia or New Zealand or Japan, there's actually assessment exercises where your university is ranked based on how many papers you put out, not as heavily on how many data sets you make available. I think that there's that aspect. There's also the training aspect, but I think that it all kind of comes down to what is inherent in how we teach people how to go through the scientific process. That it's, the equivalent of teaching someone how to clean their room when they're 15. Of course, it's going to be a disaster. And so it doesn't help that process, but I don't think it's necessarily just training or just funding or just how these things are measured and rewarded into university systems. It's again that needing a holistic view of how all of the stuff works together. But I think that that's a really valid component that needs to be incorporated as well.
Do you think there's a component in terms of community, of connecting communities? I guess you were saying about the open community earlier, and we just had a discussion at lunch about sort of opening up this community and thinking about how it's a clique of people, and those are the people doing open stuff. I mean, you see this in science all the time, right? Those are the people doing high throughput data. These people doing hypothesis-driven data. I don't know. Maybe there's something we can learn from how people bring together communities that would help make that less. Maybe we're too divisive by being open or in some way labeling ourselves one way.
So one thing that's really frustrating, and this is as someone that was involved with the actual sort of crafting of the principles of open science back in, what was it, Jonathan, 2006, 2007, we were doing that? When we were really getting the door shut in our face when we were talking about open access, they were laughing us out of the room. So we're talking about reproducibility and code and stuff like that. I mean, it seems like eons have passed, but we've now seen this is where our work is really centered, that we've seen such an explosion of activity, which is wonderful, right? Like the fact that open access isn't no longer, well, in some cases it still is getting us that same pushback, but the fact that we've now moved forward to looking at data, to looking at code, to looking at other research objects, et cetera, shows that we've made progress. The fact that there are so many tools that we've heard about, not only through BOSC, but also through the rest of ISMB, and so many advances that have woven in those tools and tracking provenance, that's progress. But the fact that that is still so separated from actual practicing researchers writ large, it's still such a small drop in the bucket. for me, as someone that like really deeply believes in open, is incredibly frustrating. Like I love seeing you all because many of you are friends, but I'm getting kind of sick of having the same conversation, right? And I know that Titus yesterday, at least from Twitter stream, it could have all been a lie, from the Twitter stream was talking about software carpentry. I mean, we've had over 3,500 people that have gone through a training of some sort or another. I think maybe almost 3,700 in the last year alone. And the majority of the people that are going through those trainings don't self-identify with open. And I think that that is quite possibly the most exciting thing about how we're doing it. It's like getting someone to go on a diet by making kale really delicious and not telling them that they're eating something fibrous and like low cal, right? Like it's how can we work to bridge those conversations? And I'll tell you outright, it's hard. It's hard. There's a reason it's easier to get traction in communities where people are already working in that space. There's a reason that a lot of these conversations are, a lot of the tools that are being developed, there's a lot of technical debt, there's a lot of investment in things that are doing what someone did, but with a slightly different user interface. And I know it's frustrating, but all of this stuff needs to continue to move forward, and there need to be people that are gluing this back and pulling this back to the way that we're working with people that are coming through the universities, are coming through various institutions, even earlier on than just graduate level, because I know it's easier to reach grad students than undergrad sometimes. But that's at least where our focus is, because the community aspect is something that needs to be woven, and the education aspect needs to be woven into everything that we do, and every conversation, every design decision about how to get that moving forward, at least if your end goal is to actually change behavior.
Oh, sorry, you were reaching for it.
Sure. I would just say that I think I came through two labs, very large biology labs, graduate student, postdoc, and Hilmar's just wrong. It's not that he's seeing a fraction of the researchers. There's a vast dark, I'm not sure what the right word is, there's a vast dark body of researchers who have never heard of any of us, never heard of any of the principles we care about, and we need to reach them if we actually want to change things, and that's going to be a lot of work, and that's one of the reasons why we're both involved in software carpentry.
So when I'm talking about reproducibility, I don't talk about reproducibility actually, I talk about productivity, because we tend to think about reproducibility is good for the community and it'll be good for you. But actually, and that's one side of the equation. But the other side is, if I improve my personal productivity of my lab, and as a side effect, things become more reproducible for the community, then I'll feed into the reproducibility cycle. So if you think about reproducibility and productivity being a kind of cycle. And I think a lot of the conversations have been about, eat spinach, it's good for you, and that makes everybody more productive. When in fact we need to do, how do I help the individual become more productive? And as a side effect, it will become more reproducible for the community and more remixable and more reusable. And that, I think, is something we can do because we're BOSC, because we can help the tools to make it easier. Because otherwise, it's just like, let's change culture, let's change society, let's change everything. And, we're BOSC, we're geeks. What are we supposed to be doing? How do we do that? But we can help build tools that make it easier to do this for the community and make it more productive, and therefore ultimately feed into the cycle. So I think it would be good if we could have from each of the panel that remains one thing they think that people in this room could do this week, this month, this year that will contribute to reproducibility for the community. Something that could actually just do because we have the skills to do it.
Okay. Do you want to start first?
So maybe I would just say this because I'm working obviously for a journal, but actually I think as being a scientist, publish openly and publish with journals that allow you to get your data out there, to get your software out there, because that's going to be helpful. The researchers you're trying to, that you're reaching out to are researchers that are used to thinking about papers, are used to reading papers. That's how you reach them. They want to know it's peer reviewed, so they have some confidence in what you're saying in the software you've produced. So I think that's coming from me.
Okay. Do you want last word?
I have something very simple. Watch someone untrained use your software.
That's a good one. Mine would be, if you believe in open, or you believe that you are working in open, interpret that however you want, right? Like, if you're a believer in data sharing, if you're a believer in reproducibility, all these sorts of things, my challenge, my takeaway for you is to find a way to cast that without using the words open in a means that caters to a young researcher's self-interest to advance, and to get them to adopt it by casting it in a different way than saying it's open or because it's good or because it's right. That would be my short-term goal. I hope that that's not the long-term, how we are only going to be able to see progress, but I think that worrying less about the binary, presenting it as a binary, because it's really easy to turn it down when it's open versus closed. Closed sounds really pejorative, but people are still going to go on with the way that they do things. And finding, like, this is why I think software carpentry has been so successful, is that we don't brand that as open science training. We brand that as, this will shave a day a week off of what you do. Like, who would turn that down, right? But on top of it, I think that data is going to be the big equalizer for a lot of this and get people to interact with one another in a very different way. And there's going to be a need for people to make things available. There's going to be a need to share best practice, because we're going to be across disciplines, both within universities and also outside, dealing with so many data challenges that someone that might be working in archaeology could have something to actually share with a biologist. We find that some of them have actually similar profiles. And so, find a way to explain it in a new fashion that could get someone to embed it in their day-to-day work.
Awesome. I think this is actually we're running out of time, so this is an awesome way to wrap up, because we're talking about positive, actual things you can do. So just to kind of try to summarize the discussion, if I can remember everything. We kind of stopped at the beginning, everyone's talking about reproducibility, defining what we mean by reproducibility and remixing, and then we started to actually get into the components of what it means to get people to reproduce things, which we talked a bit about sticks, right, and funding, and I think one practical thing that came out of that was we need to be better as a community at defining what we want people to do, right? Like, so we need to tell journals and tell NIH what you would like someone to do if you could make that decision, and actually not just argue about it for years, right, but come up with something that you can give to people that they can do. And then I think we start talking about sort of how we can reach out to people who are not members of this community, 99% of people who are not here, right? And Titus is being all negative next to me, so I can, but reach out to those people. And I think the sort of emphasis was on, we're building tools, right? How can we train people to use those tools instead of just building the tools and being mad that no one is using them, right, or that they shouldn't be using them? How can we maybe that's because the tools suck, right, or they're not good enough to make it easy enough for people to use, and the way you can make them better is by teaching it to people, learning where they're not good at it and where your tools are bad, and making the teaching better and making the tools better. Seems like a sort of a productive thing we can all, as developers, we can all take out of this. So thanks all for the discussion. This was awesome. You guys are great. And thank you, Phil, who's gone. And Noma, you have some last words.